All right, welcome back, friends. Hopefully, spring break was great. Kind of getting back into a routine here with algebra. Uh, I mentioned this to a few of you prior, but what we're going to do is we're going to kind of take a break from chapter 8. We're going to take that second half of 8. It's a little difficult to do kind of virtually, so I'm hoping to resume that when we get back together. Dealing with it deals with quadratics and what do you do when they're unfactorable, and how can we use can we graph them or look at different forms and that sort of thing. So we're gonna take a break from that. We're gonna put on pause, and we're gonna go to a newer concept. It's in the second half of chapter 9. So we're going to start with 921 and kind of trickle our way through chapter 9 till the end. Before we do that, the first part, 921 and 922, we're going to review right now, and it deals with inequalities. So inequalities, we're going to review what an inequality is, how is it different from an equation, and we're just going to review some basics to help us kind of go through this chapter. So inequality is a review. Remember, we have four symbols. So the reason we have four symbols instead of equal sign for an inequality is we're talking about a solution set. So we're talking about not just one value that makes a statement true, but we're representing an infinite amount of solutions that make a statement true. So again, we're talking about a solution set versus a solution. So our solutions fall within the solution set. The four inequality symbols compare to a value, compared to a boundary point, which we often referred to it last year. So just to review, we have a less than symbol. A less than symbol, remember, deals with an open circle when graphing or representing that solution. It's open because it doesn't include that value. This differs from the less than or equal to symbol. So we have the less than symbol with the line underneath representing can also be equal to, so it can satisfy one or the other. We fill that circle in because it includes that boundary point. Greater than, open circle, doesn't include the boundary point. Greater than or equal to includes the boundary point. So we shaded it. So let's just review that in our graphing solution sets. So here's the solution set. X is greater than or equal to -2. So we put our circle, we draw our number line, we're representing the solutions on a number line, and our boundary point goes at that circle. So another way to think of this is all values greater than or equal to -2. So on my number line, where are my values greater than -2? Well, they're over here. They're in this spot of the number line. So in the continuation, so we are going to shade all of those values that satisfy the solution set. Remember, we're representing all values greater than or equal to -2. Now, it can be -2 because it's also equal to, so that gets that filled in circle. And that is our visual representation of x greater than or equal to -2. B, x is less than 5. Boundary number 5. Open circle because it doesn't include 5. And where are the x values less than 5? To the left. Those values are less than 5. In C, we have what's called a compound inequality. So we've got two boundary points here. So I don't need the 1. I actually need 2. And I'm going to put them -1 and 4. Let's read this left to right. -1 is less than or equal to x. X is less than 4. All right, so this gets an open circle. This gets a closed circle. Now, -1 is less than my values of x, so it has to be the lowest point. So that means I'm going to shade above it. And x is less than 4, which means I'm shading to the left. So it's actually a little different than we're used to, but this is what's called a compound inequality. We kind of have two boundary points, and anything within here, except for 4, is going to satisfy this inequality, or it could be in their place. One more that I don't have on here, I'm going to add real quick, is if we had something like this, 4 is greater than x, and we kind of just saw it there. A lot of times students want to shade the direction that the inequality sign is pointing, and that's not the case. So here I'm going to put a 4, not equal to, so I leave it open. Now, if I were to switch this around, my inequality would have to switch as well. So if I did x less than 4, notice how the point of the inequality is still facing my x. x is less than 4, that's this direction, which compared to the original inequality is not the same way it's pointing. So we gotta resist the urge to follow that thinking and really make sure we're representing what the statement or what the inequality is telling us. All right, let's look at another review piece, writing the inequality from the graph. All right, so what is this visually representing? All these numbers are greater than 1, including 1. So what does that look like? Well, all of our values are greater than 1, including 1, or greater than or equal to 1. In B, all of our values are less than -3, because -3 is a boundary point. Does it include -3? No, it's an open circle, so we will not put an equal to on our inequality symbol. And C, why not look at a compound inequality again? My values are in the middle between 2 boundary points. I'm going to start with this one. Less than or equal to 3. -4 is the lowest point, and it's lower than my values. So -4 is less than x, and x is less than or equal to 3. All right. Last piece of review, solving linear inequalities. So now we're going away kind of just from the variable compared to a boundary point. We're going to look at it within a solution set of an inequality that's linear. All right. We solve inequalities just like we solve equations. We're going to draw a line down our inequality symbol and go ahead and solve. So we're going to add 5, bring down my 2x, makes 8. Because it's an inequality symbol, it stays the inequality symbol, greater than or equal to. Students often want to change them to equal signs or do so just kind of through habit. So that's something you want to be careful on when solving. Divide by 2. X stays greater than or equal to 4. And that's going to be our solution set for that linear inequality. Looking at B, I'll change pens here. I'm going to draw my line down my inequality sign like I'm used to. I'm going to take away 3, -2, keep my inequality symbol to match. Now here I got to be careful. I'm taking away the 3, but I got to make sure I don't lose the subtraction masking itself as a negative or vice versa. So we're going to keep -2x here. All right, now to solve here, divide by -2. This is where we have to be super careful. It's the one difference between solving inequalities. Dividing by a negative value. If at any time solving inequalities we divide or multiply by a negative value, we have to flip the sign around. If you remember that from 7th grade. So -2 divided by -2, x stays x, but instead of this less than symbol, I'm going to switch it around to a greater than symbol. -2 divided by -2 is 1. Here's my solution set. Looking at C, I'm going to draw my line. Let me switch to red. Here, I multiplication, divide by -4. X. Now, I divided by a negative value, which tells me I have to switch my less than symbol to a greater than symbol. And 6 divided by -4 is -1.5. And that is a review of inequalities that will help kind of carry us through when we start talking about the rest of Chapter 9.